Welcome back, guys. So, yesterday we were going through in general, the article for X4 file system and other documentations to figure out what are the parsing structures that we need to care about, and in general, to write a parser for a file system in our own kernel. And we are gonna start with supporting X4. I guess it's a well-known file system, and we have taken notes of what are the things that are possibly what is the general structure of a system, and what are the things we need to parse from it. And today. And one of the things that was troubling us yesterday was that because it's Mac OS, I'm not able to mount the system directly for some reason, and it just does not seem to be working. I don't know. I'm not sure fully, but right now the X4 image just does not seem to be mountable. I'm trying to do that because I have this root image which I know for sure is a valid image, and I have worked with that in my first few videos or something like that, and currently it just doesn't work. We're not able to mount this image inside here. Let's say just we mount this to root.fs. We just get invalid file system for some reason. And if we provide tx4 not good enough, and I just get it is trying to move and this is the error that we are getting. I was thinking maybe we could just move this entire thing to at least writing a prototype for X4 file system. Maybe we could just directly move it inside the Ubuntu kernel and use it directly here. No, I mean within Ubuntu VM, and check things there and bring the code back into our kernel once we have a running prototype. That is what I was gonna try. It is going to be a bit more tired because it's just I have to do everything inside a VM, and I won't have a proper editor. I don't know. I was just thinking whether if I should go with it or not. I haven't completely decided it, but my idea is to implement this X4 file system parser inside Ubuntu, test it out for a general image, see how things works, and then based on that example code I can write the actual implementation in this kernel code. So I would have some basic idea of how things work, because here right now there's no way to test it because we can't directly run this inside our kernel and test it because there won't be any feedback in general. we'll probably have to do a lot of duct taping to even uh, bring this to actually reach the file. So I don't think that's possible that way. So let's just implement the X parsing separately and then bring it back into kernel. That is what I was thinking. Or maybe I'm just complicating it. Maybe you could just simply write this here. And call wait, let's just think about it. So we have our bash and we have our kernel commands currently. It's we are loading the kernel ELF in this location. That's it. But is it possible to provide a file system directly here, or we may have to write a temporary file system and then jump into it? That depends upon how my kernel is going to jump. So kernel will start executing from here, and then it's jumping into the virtual management, virtual memory, and where do we actually oh okay, maybe the user process that we are jumping into, maybe we can consider that to be taken from the actual file system. But to do that, I might have to do lots of stuff around it. So I don't know, first of all I need to test it. I can't simply throw in code and expect it to do something. So let's if we add those things, let's think about how we currently hold our user process. So currently I have two user process. So technically our file system should hold the ELF file that has this code, has this bytecode or assembly with its virtual host layers and link binaries, etc., stuff like that. So when I'm trying to init, instead of giving it a kernel, giving it a user entry, instead of giving it a entry, I should actually, technically we still have to read from the file system and load it into RAM and give it here. So I think here nothing changes, but before init task we might have to probably have some helper. There is load task from memory, and that would be our first task that is loaded from the memory, and we'll have to write but because it's kernel, we don't really have to rewrite syscalls. We can write the actual layer here. Maybe we don't have to have the extra VM. Maybe we could do things here. Okay. Okay, let's think about it. So, in case, let's say I want to write something here, something like file, that is task, no, user one, user process one, no, user process file one. Okay, and then I would have to load it from file like open. Here I don't have to really call open, do I have to, because I'm inside kernel already. So probably all I have to do is just well, how do we open a file inside the kernel? I mean, if we are already inside the kernel, because if we are in the user layer, we would call the syscall to open the file. But if we are already inside, maybe we simply call something like fopen or some kernel open, which is internal, and we pass the file here, and it would be root test 1, and it has to load it from here, and it would give a file handle, and then I'll have to read the input and put it inside no currently I just need I read from this file and I copy all the contents into memory, and so I just allocate some space and I give it back. Okay, let's just see how to pass file ext4 file system in Kernel. Okay, so there's a drive option, and you give raw. I think we don't need this one. If the X image contains a bootable OS, you may, I mean, it does not have a bootable OS. Okay. Because right now my entire kernel is already booted inside the RAM. How does it? Yeah. Because I have a kernel ELF and it's directly placed at this location. Currently we are just going to use that as a secondary drive, because our kernel just directly loads into it and it's already in our virtual space, so I mean already in our physical RAM, so it should be good. Let's just try this. So we're gonna create a ext4 file and use it here. And it's going to be drive file equal to, let's name it drive, E drive, C drive, what the fuck do I name it? Test drive, drive, data, no, just hard disk. Okay, disk seems, disk ext4 format is wrong. I think that should be good. We don't need media. Do we have to give media? I don't think we have to give media. Yep. Yeah, should be good. Should be good. First, now we have to think about which memory mapped address will give us access to this drive. Okay, how do we access this drive from bootloader? Drive, which is the memory mapped, right? It must be memory mapped. I don't know, but we'll think. No, I don't freaking understand. I mean, it is block based. No, because currently I have no frame of reference for how exactly to. So, okay, let's say it is drive. Then inside my kernel, how am I supposed to? I am writing my own kernel, and my kernel is running in Kemo address exe. So now if I add this drive option to my Kemo, how exactly should I reach this drive from my code? That does not make sense. Either it's memory mapped. Okay, so because it's a block drive, so it's not memory mapped. And how the fuck do I reach this? Either it's memory mapped, or what else? What other options are there? Maybe I'll have to write some. Oh, okay, yes. Simply I could just check the check my device tree and see what's added there. Okay. Okay, first of all, then I have to write a driver for my physical drive. But isn't that the file system? No, I'm fucking confused. Okay, we might also have to do uncatched and strongly ordered. This is what we do for UR2. Okay. I guess we have to do the same fucking thing here. But this looks like a device driver. Why do I need a device driver? And what exactly does a file system driver do? Okay, so the file system driver will interact with this device driver. Okay, so on top of this I can write my own ext4 file system. You need to pass manipulate on raw show. Okay, so I need the driver layer that is gonna do memory mapped IO to do physical reads and writes to the ext4 image, and then on top of this I have file system layer gonna use this read and write to write the ext4 parsing. Or am I missing something in this flow? Okay, so map the virtual IO region into my kernel virtual memory. Okay, that's fine. Implement virtual block read device status, negotiate features, set up which queue in device, whatever the fuck that means, submit requests via descriptor chains, poll for completion in the used string. Fuck me, okay. And then we have the block layer, translate sector numbers to fiction, the steam. What the fuck? Okay, so there is and then we have the upper layer that is going to parse block block descriptors. I know it's used to read stuff, whatever. Okay. What is this then? Which IO? Maybe I'm just looking into the wrong direction. Okay. I'm only finding new layers to implement. And every time I start to believe that this should be the layer, and let's start implementing it. I find a new layer. Let's start something new. My kernel and a new drive and what is the flow? Finally, I want my own kernel to have X4 file system support, and in Kemu layer I'll pass a drive with file equal to xt4 and format raw. What are the things that should happen in between? My kernel, I need a virtual disk controller, something like virch.io, and I need a block device driver in my kernel, and I need a block layer abstraction, and I need buffer cache or page cache, and I guess this is my file system layer, and I have the syscalls. Okay, I have 3 things in between. Fuck me. So Camus just does not give, because there's no such thing as memory mapped disk. So I guess we have to ask Camus to make this device supportable for Virch.io, and we need a device driver. And we have to probably set up this Virch.io like device driver. And finally, because X4 is just a parser abstraction, finally, directly when we think about the physical layer, we only do block level access. Okay. I think I don't need this layer. We'll think about that layer 1,000 years later. Next, driver layer. Okay, this will be the higher level layer that I have my explanation. So that would be like the fifth layer. The first thing I need to do is I need block driver. I think first of all I need to do this part. I need to write something like this, I guess, because I do have drivers and I have IRQ driver, which is the fucking no. I have a UART driver. This looks almost similar. We are writing to something and we have lots of mamo, and read, write, put. Probably we are going to do the same fucking thing for this block. Okay, explain the structure for writing a block driver for X4 image in Camus in which IO modes. What are the structures that are needed and why do we need that, and how Linux implements it. Okay, so we pass Camus with this argument, that is file as x4 raw, and let's also pass if Virch.io. For some reason I have decided that Virch.io is good, but maybe if it is not good, we'll think about it later. which IO and which IO device block. So we need some sort of PCI. Your block driver does not understand X4. It only understands read N sectors starting from LBA without into this buffer. Okay. So it's simply just going to read sectors and put it into buffer. Okay. So it does not even understand blocks. It simply understands sectors. What is a sector? It's a PCI device. You must find it by scanning PCI config space. Okay. Modern which IO uses PCI cablets for common config notification and device specific config. Which IO block request structure? I didn't understand a single thing. Okay, maybe this will help. I didn't understand anything. Give me ASCII flow for one full read file from my kernel to the lowest bits possible. Let's see. First of all, let's fucking understand a picture and then think about anything. Okay, user program calls readFG buff 9000 and my syscall should be whatever syscall it is, and my VFS layer should find the struct get inode and leave that part too, and I have a X driver that is just going to, this is the layer that I thought I'm going to write. Okay, but below that I guess I'll have to write these 3 layers. Okay, I have to write a block device driver. Okay, so my X layer is going to send X for inode, offset and size, and I have to find the inode, parse the tree, translate the offset into file system block, call block. Okay, what is translate offset, file offset into? Okay, maybe that is just like finding within which block within that file system does this file exist, and then we have a block call block readfs. So we have block read is a device, sector and count. Convert request header, create descriptor chain, add to available ring, notify device, wait for completion. Oh my god, there's a lot of stuff. Which queue? And it's a descriptor descriptor table, available ring, and used ring, and we have the camo. And fucking leave this because camo is going to support everything else. So we probably have to implement these three. Currently having a working kernel. I was thinking about adding support for ext4 file system. My kernel has no device drivers for file systems. So I explain more about okay, I need a your X code works in file system blocks. Typically, X flow block is a size. Your disk works in 512 byte sectors. Chalks to which your file system becomes hardware dependent. Okay. Okay, that's why we need a block layer. Maybe we can just write a hardware dependent code now. Or okay, which IO should not directly call a read sector from which IO? It should call block read. It's sector number 8 sectors. Then call the count. Read port and get data in stateless. Prepare a request. Place in shared ring. Notify device. And device writes results. Okay. Message passing. Okay, so first we build a header. It has a type, it has a result, it has sector. Wait, fucking wait. My head does not work. Okay, maybe he has already given an example here. We have read. It translates to block size of 1004. File system block, so we find the block. Let's say it's 1, 2, 3, 4. Per sector, so one block is 8 sectors, so this is 9872nd block sector, and then we just create a header request with type read and sector, and you give a buffer and status bytes. And we put this index into a ring and notify the device. Okay, I guess we only have to do till here. In our kernel, we can write a simple example that just reads the test file. First of all, we have to have a test file inside that. Wait. Pretext for simple file system image. Mac OS does not have MKS. Fuck. It does not have that. Okay, this is almost like what we tried yesterday. Okay, we'll try this method. Kernel dev, we'll go to kernel. We create file, and we have the first one. We should put MBR. Next for fs, and we'll put pwd next for fs. Okay, and we'll give, I guess we can do these steps manually. We create 1 GB I can just put count as 1. Count as 1. And yeah, and I just call this to create the image, and then I mean I can show the setup, but that doesn't. Okay, this will give us the actual device that is mapped into, and use that here. Okay. Okay, let's try. Okay. X4FS, and let's do this. Okay, I need to start Docker. Okay, started. Do I have my X4FS? Okay, I have it. Let's create an X4 image. Okay, we created 1 GB X4 image, and let's do the rest of it, and we have it in this. Now we can do the same thing again. Now we have actual X4 as an image, and I can maybe create a file. I don't have Vim, I guess. Cat UF. This is for test UF. CD test. What? Cat test. Touch test. Cat test. CD test. Fuck me. Okay, I'll just put here code in. The test. Test. What the fuck? It took new line as just slash, yeah. Okay, whatever the fuck it is. Let's just do we have to unmount it? I guess we'll probably have to. Yes. What about my X4 here? Again, here it does not say anything. Okay. Maybe I should have done it a bit better. Right. Kernel. Oh fuck. CD create, and let's just put all these. Okay, now we have the. Oh fuck. what did I do? I created image, mounted that into, oh fuck it, ls x4. Underscore of x4 and kdr x4 fs. And I do everything in the roots. ls x4. Okay, I fucked up because when I created it again, now I got a div loop too, but my command just copy pasted just ls30. So, but whatever, but I believe the current image unmounts, you mount x4fs. And if I try ls, okay, I'm fucking confused now. Wait, we created currently our x does not have anything. Now we just have to create let's create this. Now ls x4fs, there's nothing in it. I mounts dev loop 3 into x4, then I put ls xfs. Okay, now if I go to, I can touch, I just put echo, this is for testing into x and test1, and I put you mount x xd first, and if I try x4s, there's fucking nothing there. I don't understand. We are mapping the directory into here. How the fuck will we? Shit show. Just does not have anything. Why? I don't fucking understand. But if I simply create this, and if I put this, and there's nothing here too. Maybe I just have to copy the image. Because that is what finally can help me. Okay, let me try that then. Oh shit. I just get into more loopholes. Wait. Last dev loop 0. Okay, whatever. Now I have x4 fs image. And let me mount it. I think I'm not getting it. Why are we created an image and we checked, and this is currently, what is LO setup mean? Man, LO setup. No, there's no fucking man. What is the fucking LO setup? Attach a file to a loop device. We get a loop. What did we do? Yes, we showed that device. Okay, so whatever we write into this loop will be automatically written into. and finally we mount dev loop 5 into xfs. Okay, now we have, I believe we have mounted that image into this extension. Okay, so if we have done that, why can't I echo for testing into test1 and then I go back, unmount x4fs. Okay, if I now remount this to here and put lsx fs, it's still there. Maybe I have to just unmount it. Finally detach lo setup -d dev loop 5 loop 0 1 2 3 4. Yes, there is no loop 6. Okay, that's fine. Now let's see if the next 4 image has gotten any better. Okay, it's 1 GB and it is an image. Okay, now let's try to mount ximage to x4. When did we mount that? Okay, unmount x4. Now if I just directly mount this, if I go to fs, okay, it is there. I put and I unmount it, but this fucker said just by mounting and adding stuff and exit the container, then your host will show the new raw ximage. How the fuck will it show that? Wait, what did he mount? He mounted home fs into fs. And we directly created it, so we are actually probably inside the root. Yeah, he just did not give us the information about copying this fucking thing out of the container. Is there any easy way to do it? There's definitely one easy way. I just put cp x image to xfs. Now I should have ls LHX, and I have the image here. Okay, I have an image which I already had previously somewhere else, but at least I know this image has only one file that we can read. We can use this as an example image. Let's just put this here. Add files to the mounted directory and unmounted. Next 4fs, and then call cp, and it should be good. Okay, makes sense. Okay, we have a X image. Now we have to use this as the actual image as our this will be our X image. And it's going to be a rich IO. Now we can do what? Now let's just write a rich IO layer that is simply going to start a request to read from from starting blocks randomly and see how it works. Because we have this image, we can actually try to write an example that can read just that can just read the file, the test file that we created. Okay, so we are going to write a new driver, qcar, and let's put a block driver. Block, and with block driver.h, and define if def and if define drivers, and let's start. We need an example. We have an image xt4 that has a file test. We have to write a a block read and block write operation that is manually gonna read and write to this image in block levels, again sector level, so we are going to have this block read, and it's going to take a device and it's going to say 1024, just read those 2048 into the buffer from the 8th sector or up to the 8th sector, I don't know. We can do this inside this file is never linked anywhere, so I guess this should just be fine. We'll come back to this implementation after we are done with the block driver, because I guess block driver sits right above the QEMU, or at least that's how I believe. Okay, to get, first of all, do I need to pass the device tree of Kimu and Jirex photos and to read the newly added device drive. Oh fuck. Wait. I'm using Camo. What am I using? Arch 64. Okay, so device tree will have my, okay, so DTB will have my, okay, probably I'll have to parse DTB. Do we need anything from this first of all? Maybe we need the register. Okay, so we need this address. Map it. Initialize device. Holy fucking moly. What devices exist? Okay. I think we have code that does that. Where is that? Where do we find? Where do we parse DTB? I am sure we are parsing it somewhere. Okay. And it's a hard-coded version because I only needed to read the total RAM. So this is fucking hard-coded. So I get the DTV. Okay. This is my fucking get total RAM. Now I have to add a new function that is going to probably it should return lots of stuff. It should return what else? If I enable the kernel, I will have better if I call it like from the beginning, I don't have to do mapping for this address because I might need that page table entries for 4000. I think I can just do it after I start my kernel because that way I can. Anyway, I have to map some extra registers. Yes. Okay, at least now what I have to do is so now I need a DTB parser that can parse the I need to understand how to fucking do this first of all. To understand how to parse the DTB to get the needed information. I already have a function that gets the total physical RAM value from DTD. This is my fucking yes, DTB. So we need to extract the base address. We need the size and interrupt number. Yeah, begin prop, begin prop, end. Extracts its reg property. Fuck me. There's just a lot of stuff to do. Me to do two things. At least the next thing will be the final thing. I don't want to go deeper than that because I'm just keep on going. I'm finding more things to implement. I haven't implemented anything yet. I'm just finding new things to implement. It looks like an endless loop. Before that, parse DTB to get virtual, get the address, and what do I need? Get the registry address. What is size? Why does which MIMO has a size? Maybe we'll just say interrupt number. Why do we even need a size? Why do we need the MIMO size? Two completely different sizes. Okay, so probably it's just the number of registers, region. I don't know, but registry must be just one address, right? Why do we need multiple? I have no fucking clue. Let's just get the registry address and interrupt number. This is hard to do, fucking to do. I guess if we have this, then we can actually write the block driver because we started off by saying that we are gonna write the file system, and then we thought about writing the X4 file system, and then when we managed to find all the structures for X4, we found out that X4 layer is not the final layer. X4 layer can't really access the physical Kemu drive images. We probably need another layer called block layer, and that layer is what currently is we try to so to even start writing that layer, we need the registry. We wrote a simple helper image that has one file, and what we are going to do is that we are going to find out the registry register for this particular drive, and then implement the block read and block write on top of it. I think so. That is what we are going to do. Okay, let's see. Okay, I guess I'll do this next week. Even it's just already too much data to take in. Thank you guys. Bye bye. See you next week.